Good morning, and welcome to a little bit more unusual episode of The Angry Astronaut. But before we get to the topic at hand, let me give you a quick update on a couple of issues. Number one, we are sitting at 5,875, at least the last time I checked, subscribers away from 100K. And thanks very much to all of the new subscribers that we have at the moment, because back in November, I was more than 13,000 away from 100K. So we've had a lot of growth, obviously, since then. But we have one last hill to climb, and I know we can do it. Please subscribe if you haven't already done so, and I know there's a lot of you out there. Many thousands of people who check out my videos are not yet subscribers, so subscribe. And secondly, as I mentioned yesterday during a live stream, I am hoping, or at least looking at the opportunity of watching the Rocket Lab launch from Wallops Island in Virginia. In order to do that, all I need to do is drive for 8 hours and get lodging, gas expenses, that sort of thing. Under most circumstances, that would not really be a problem, but I get paid once a month. I won't get paid until after the launch this month, and so as a result, just looking for a little bit of support in order to get there, assuming that you guys are interested in me covering the Rocket Lab launch, the first ever Rocket Lab launch, by the way, from North American soil. Pretty exciting stuff, but once again, that is entirely up to you, and thanks so much for the folks who have already supported me on PayPal. I can guarantee you, if I do go, I will give you some really good content, very similar to what I brought you from Cornwall, except this time we'll have a launch. Let's move on. So, antimatter. This is something that I have discussed before on this channel, but it was well over 2 years ago, and I stand beside my claim back then and the same claim that I have right now, that we are actually much closer to antimatter propulsion and antimatter power sources than most people would think. And why is this the case? Well, it's not because we have the ability to manufacture enough antimatter to actually be useful. It's entirely too expensive, entirely too energy intensive. But the thing of it is, we've already found antimatter in orbit around our own planet, and it also exists in greater quantities throughout the solar system. And by greater quantities, I'm talking quite a few kilograms worth of the stuff, which would be able to generate enormous amounts of power and propel spacecraft to speeds up to this point would have been regarded as completely impossible and beyond our capabilities, at least for the next 1,000 years. However, it's not really the case. And for those of you who may have recognized the thumbnail and the avatar ship, that is actually an extremely scientifically accurate ship that was designed by an individual who put forward a proposal for a spacecraft that could actually travel at 92% of the speed of light. And we're going to find out all about that in just a moment. So what is this nonsense about antimatter actually existing in the solar system or even orbiting our own planet? As we all know, antimatter can't exist in our universe without eventually colliding into a chunk of matter and the two of them annihilating one another with a tremendous release of energy. That being the case, how could antimatter possibly be orbiting our planet? Well, believe it or not, it was recently discovered that antimatter is is being created by thunderstorms all the time in our atmosphere and are being driven into our planet's magnetic field, where they are insulated from particles of matter, thus preserving their longevity at least for a while. And this was discovered by the Fermi Gamma Ray Telescope over 10 years ago. Fermi was designed to pick up things like black holes and supernova explosions, which generate a tremendous amount of gamma ray emissions, but at the same time, it picked up gamma ray emissions coming from our own atmosphere, or more specifically, from a thunderstorm that was going off over the horizon. Now, how would this even be possible? Well, this is what happened. The thunderstorm tosses electrons at nearly the speed of light into the atmosphere. These electrons then collide with atoms, giving off a burst of gamma ray radiation. On rare occasions, that gamma ray radiation collides with another atom, giving off an electron and what's called a positron, a tiny particle of antimatter. And a large number of these positrons were emitted along the magnetic field lines of our planet by this thunderstorm. They followed the magnetic field lines, again protected from the surrounding matter, until they hit the Fermi Gamma Ray Telescope. When that happened, they collided with electrons that were inside the telescope, that is simply part of its structure, and they annihilated one another, giving off gamma ray bursts. Very powerful gamma ray bursts, at least as far as the telescope was concerned, given the fact that it was supposed to be detecting gamma ray emissions from millions of light years away, and instead it was picking up gamma ray bursts that were being generated by the telescope itself, as crazy as that might sound. And this happened on 4 separate occasions. This telescope has detected antimatter several times now, and scientists are convinced that there is a substantial amount of antimatter hiding in our Earth's magnetic field, and more gets created with every major thunderstorm. That being the case, there may be more antimatter in far more powerful magnetic fields scattered throughout the solar system. We're talking many kilograms of antimatter in the magnetic field of Saturn, for example, which seems to be a prime candidate for antimatter collection. However, antimatter also arrives in our solar system from other sources. The Chandra X-ray Observatory detected an enormous amount of antimatter stretching for trillions of kilometers being generated by a pulsar. It's been estimated that at least a kilogram worth of antimatter every second arrives in our solar system, having been created by pulsars and other violent astronomical phenomena. This antimatter is then gathered up by the magnetic fields of various planets throughout the solar system. The more powerful the magnetic field, usually, the more antimatter gets gathered. However, Jupiter seems to be an exception to this. Its magnetic field actually acts as an insulating shroud, keeping the antimatter away from the planet. It seems to be sort of a unique phenomenon throughout the solar system. However, the remaining planets that have very powerful magnetic fields also have a considerable amount of antimatter. But our own planet also has an abundant source of antiprotons. It appears to be in a thin belt that extends from a few hundred to about 2,000 kilometers above the Earth, moving along Earth's magnetic field lines and bouncing between the north and south magnetic poles. This was discovered by an instrument called the PAMELA, or Payload for Antimatter Matter Exploration and Light Nuclei Astrophysics Scientist, which was a joint mission from scientists from Italy, Germany, Russia, and Sweden. What does this mean? Well, it means that we don't need to spend trillions of dollars making micrograms worth of antimatter on our own planet. We can instead harvest it throughout the solar system. But how the hell do we harvest it without destroying it? Because after all, it annihilates any antimatter that it comes into contact with? Well, by using the same principle that we use in order to contain ionized plasma in fusion reactors right now. And once again, we already have the technology to do this. Remember that positrons are, by their very nature, ionized. They are ionic and therefore magnetically charged particles that can be gathered by the magnetic field of a planet or by an artificial magnetic field that we could gather ourselves. If you could contain antimatter inside a magnetic bottle, yes, that sounds very much like how they do it in Star Trek, doesn't it? Then you could keep the antimatter insulated and safe for use as fuel. However, contrary to most science fiction applications of antimatter, you wouldn't actually use the antimatter as a power source to drive your ship. You would instead use the byproducts of matter-antimatter annihilation in order to drive your ship. Let me give you an example. Let's talk about an antimatter sail. You may not have heard of this, but it is a very interesting idea. And by the way, utilizing the amount of antimatter that we can actually produce on Earth, this is a vehicle, at least on a very small scale, that we could create now. Let me tell you how it works. It's a sail that's comprised of two layers, a carbon fiber sail and a uranium-238 coating for fuel. The sail actually uses fission to move and not matter-antimatter annihilation. However, you use the matter in order to create the fission in the first place. When the antimatter comes into contact with the uranium foil, a fission event was induced, and this produces two fragments, both of which have a velocity of 13.9 million meters per second, or 13.9 thousand kilometers per second, which gives it a specific impulse of 1.4 million seconds, far better than any propulsion that we can possibly think of today. So instead of using the energy from a matter-antimatter reaction in order to provide your propulsion, you're instead using the incredibly fast particles that are generated by matter-antimatter annihilation in order to generate your velocity or your momentum, in the same way that a chemical reaction is funneled through a rocket's nozzle at a speed of roughly 4.5 kilometers per second, maybe a little bit faster than that. You are instead looking at 13,900 kilometers per second, or almost 5% of the speed of light, meaning that this type of antimatter sail could, in theory, be driven to relativistic speeds of about 5% that of light. Now, it would take a very long time to reach the nearest stars using this type of propulsion, but nevertheless, it would be extremely fast. Much faster than anything we currently have planned. But could you go even faster using this type of fuel? Well, yes, you could. Instead, you would use particles called pions, which are generated by matter-antimatter annihilation, and then, since they are ionized, eject them out of the rocket, utilizing magnetic fields in order to produce the propulsion force. It would generate 300 times more energy than any nuclear fusion reaction. Annihilation of protons and antiprotons occurring in a magnetic nozzle, producing these uncharged and charged pions guided by the magnetic field would travel down the magnetic nozzle at close to the speed of light before decaying into electrons and positrons. As the charged and uncharged particles possess mass, the reaction would not be 100% efficient, but you could get about 64% efficiency, and there are ways to increase that efficiency even further. If you were to use the uncharged pions that naturally decay into gamma rays that would not be directed down the nozzle, and instead use a dense electron gas that would be able to channel these gamma rays, you would increase the efficiency to about 77%, meaning that you could achieve 77% of the speed of light. absolutely unbelievable. And if you're wondering how the hell is all of this lining up so conveniently, if you get 77% efficiency, you get 77% of the speed of light. Well, that's simply because of Einstein's classic equation, E equals mc squared. If you can convert 77% of the matter at your disposal into pure energy, that generates 77% of the speed of light. It also means, of course, that you need at least as much mass in your rocket to be used as fuel as the mass that you're trying to propel. Actually, it's nowhere near that efficient. It would be more along the lines of a ratio of 22 to 1. In other words, 2,200 tons worth of fuel for a 100-ton spacecraft. That is an insane amount of antimatter. But the most ambitious antimatter ship, which once again is theoretically possible if you can gather enough antimatter, is Project Valkyrie, created by Charles Pellegrino, who is the same person who served as a scientific consultant on James Cameron's Avatar movie. And the interstellar vehicles seen in the film are based on the Valkyrie rockets, one of which you're looking at right now. Let me explain how it works. Instead of a solid spacecraft with a rocket at the back, Valkyrie is built more like a train, with crew quarters, fuel tanks, radiation shielding, and other vital components being pulled behind the engine on long tethers. This greatly reduces the mass of the ship because it no longer requires heavy structural members and radiation shielding. Now, at first, Valkyrie works by using small quantities of antimatter to initiate a very powerful fusion reaction. The magnetic coil captures the exhaust products of this reaction, and it's expelled with an exhaust velocity of anywhere between 12 to 20% of the speed of light. In other words, up to 58,900 kilometers per second. Still not fast enough for Mr. Pellegrino, however. As the spacecraft approaches 20% of the speed of light, more and more antimatter is fed into the engines until it switches over into pure matter-antimatter annihilation, and it uses this mode in order to accelerate to 92% of the speed of light. But of course, there's lots of feasibility problems with that. For example, where the hell would you get all of that antimatter? But as we have seen, there are vast numbers of natural sources of antimatter throughout the solar system. We really don't know how much is available aside from the fact that it's many kilograms worth. Who knows, there may be many tons available given how much encounters our solar system second by second. That being the case though, let's get a little bit more into detail as to how this ship works. The ship is essentially a magnetic coil which generates a magnetic field against which particles from the matter-antimatter reaction are bounced. The magnetic field, and therefore the coil, is propelled forward by these bouncing particles. The coil then pulls the rest of the ship along on a string or tether, much as a motorboat pulls a water skier. A pulling rather than pushing engine eliminates most of the structural integrity that would be required, and that of course adds unnecessary mass, so you eliminate most of those requirements, but the tethers would still need to be as long as possible, an estimated 10 kilometers. Why so long? Well, because riding an antimatter rocket is like riding a giant death ray bomb. It gives off tremendous amounts of gamma rays, so you want to put as much distance between you and the engine as possible. In addition to that, however, you would also have a block of tungsten, approximately 20 centimeters thick, that would provide the necessary protection against the gamma rays that would still encounter your ship at that distance. But what about the incoming particles traveling at near light speed? Those would also be incredibly lethal. Well, before I tell you about that solution, I would encourage you to please subscribe to Astronaut, who provided me with this incredibly useful footage and animation details for this particular project, for Project Valkyrie. They produce some of the most amazing work when we're talking about interstellar travel. Please subscribe to Astronaut, and also please subscribe to my channel and like this video. So Dr. Pellegrino came up with a system that will perform both particle shielding shielding and heat shedding during the acceleration and cruise phases of flight. He dumps intercepted engine heat into a fluid, chiefly organic material with metallic inclusions, and throws streams of hot droplets out ahead of the ship. The droplets radiate their heat load into space before the ship accelerates into and recaptures them in magnetic funnels for eventual reuse. The same heat shielding droplets ionize most of the atoms they encounter by stripping off their electrons. The rocket itself then shunts the resulting shower of particles, both protons and electrons, off to either side of the magnetic field, much in the same way as a boat's prow pushes aside water. When it comes right down to it, this guy thought of just about everything when you're talking about interstellar travel. And at 92% of the speed of light, because of time dilation, remember, funny things happen when you travel close to the speed of light. You're looking at 2.5 years passing in the outside world for every year that would pass on the ship. This would, in theory, put star systems even further away than the nearest stars within our strike range. For example, the TRAPPIST-1 system that has 3 planets at least within its habitable zone is 39.46 light years away. It would take less than 20 years to get there as far as the passengers on a Valkyrie ship would be concerned. Less than a generation. Now, all of this is definitely far future kinds of stuff, at least as far as we're concerned today, but the important factor is we can at least conceive of a technology and a way of reaching these kinds of velocities utilizing physics and factual information that we have confirmed today, including the existence of considerable amounts of antimatter. That's something we didn't have 2 decades ago, and it's very encouraging for the future of interstellar travel. But the most amazing thing to me is the fact that the future of our species and our destiny to become an interstellar civilization capable of colonizing planets 40 light years away from our sun, or perhaps even further, was first discovered in a simple thunderstorm. Please like, please subscribe, and as always, stay angry about space.